Math. All right, guys, Mr. Elting here showing you how to multiply radicals of fractions. If you thought fractions were pretty radical before, you don't even know. Here's the deal, guys. When we do problems like this, we always multiply the insides, okay? We are not going to take the square root of 7 over the square root of 60. That's just going to be a big pain. It would be much easier to multiply the insides first. That follows from this rule that we should know already. When we multiply things that are square rooted, we can simply multiply them and then take the square root. So this is the same as 2 times 3 is 6 square rooted. Okay. Now, in order to understand how to multiply 7/60ths by 12/35ths, it's important to know how to multiply those fractions without the square root in the first place. So what we're really talking about is not a square root problem. We're talking about a fraction problem. And before we get to this guy, let's start with an easier example. Maybe a 1/2 times a 1/3. That's a really basic example. But we need to multiply the tops by the tops and the bottoms by the bottoms. Okay. So you know half of a third, if I had a whole pizza and I split it into, oh, I don't know, 3 pizzas and I have 1/3 of this pizza, okay, well, you know that half of that third is just that much. And how much is that? Well, if you split this into halves, it's 1 out of 1, 2, 3, 4, 5, 6. You could have found that much easier simply by multiplying 1 by 1, 2 by 3, getting 1/6. Now, that's all good, but in this problem up here, I really don't want to multiply 7 by 12, and I really, really don't want to multiply 60 by 35, although I certainly could do that. However, you know that when you multiply this, you're going to get a really big fraction with really big numbers, and you're going to have to reduce. But believe it or not, we can always reduce from the get-go. Okay, and I start with an easy example here. 3/6 times 2/4. Okay. One way to reduce is to reduce the individual fractions first, and you know that 3/6 is 1/2. Why is it 1/2 though? Well, that's just because 6 is actually 2 times 3, and 4 is actually 2 times 2. And if I cancel things out, when I cancel something out completely, I'm left with a 1. I'm actually left with 1/2 times 1/2, which again, we know our rules, multiply the tops, multiply the bottoms, it's 1/4. Okay. Now sometimes we might want to cancel things not necessarily under the same fraction. And let me show you a quick example of that. Let's say we had, oh, I don't know, 2/5 and, I don't know, 15/20. Okay, getting a little more challenging now. But 2/5 of 15/20 is not so bad because we know that we can simplify this fraction on the right into, well, 3 times 5. And, well, what would be a good one for 20? There's lots of them, right? There's 2 and 10. There's 4 and 5. But I would say probably 2 and 10 because I know I already have a 2 up top. And in doing so, I can go ahead and cancel those. I see some 5s I can cancel. It looks like I'm just left with 3/10. Isn't that nice? And that is the actual reduced fraction. I end up not even having to multiply at all because they cancel out. So all of that, let's go back to our original example. I have 7 times 12. I don't want to do that, but you know what I can replace 12 with? 2 times 6. Okay. And likewise, I know 60 is divisible by 6. And what I end up getting is 6 times 10. But you know what? in doing this, I'm making a realization. 12 actually goes into 60, doesn't it? So sometimes we might end up overcomplicating the problem because this 10 could be split into 2 and 5. So when we do this, a key is to remember we're actually looking for our greatest common factor, our GCF, between these two numbers. And the greatest common factor is actually 12. Likewise, the greatest common factor of these two is 7. And I cancel. The only thing left over is simply to divide, which looks a little bit like this. That cancels, so I'm left with a 1 over 5, that's the only thing left, times 1 over 5, which is much easier. That's just 1/25. I hope that helps a little bit. Try some examples on your own. All right. Good job.